All right, guys, so we got an issue. Electrical diagnostics here, working with this system, and the customer complaint is that the thermostat's not coming on. I worked on this before. I rewired this thermostat, but this is a different issue. Before it was the 5 amp hour fuse. The fuse that's in the thermostat was just blown. Rewired it because the wires were really messy, strands hanging out, things like that. Now what we have going on is the furnace. It's actually, the power loops through, goes through the furnace and comes back, and it keeps blowing the fuse for the front furnace. So I got my amp clamp set up here. Got it set for maximum DC amps using the Fluke 377 FC. Fuel sense doesn't do anything for you when you're troubleshooting DC. All right. I had a viewer leave a comment about how to zero out the DC amps. Mine works fine. Whenever I press the yellow button, which is the 0, after you have it set to DC amps, press the yellow button, it zeroes it out. Press it a couple times. If it, it's floating around, just press it a couple times. So I didn't have a problem. So got that set. So first what I'll do is I'll turn on the AC fan. Okay, so you saw what I did. So I want to see is the thermostat, well, what is it? And my amperage didn't really go up much. Turn the light on. All right, so let's see, which one is it? Make sure I'm on the right wire. This 30 amp one is the main. That one. It would appear to be like I'm on the wrong wire. I was on this wire before. This wire right here. Okay, yeah, that's the right wire. Now I'm getting some amperage. 1.2 amps I saw. So I'm gonna turn that off and turn it back on again. I wanna see. See what it is. Turn it off. And then I'm gonna see what my startup amperage is. All right, 1.2 amps. According to the key, that's only supposed to be a 15 amp fuse. Now let's turn it on high. Switched it to high. Still didn't exceed my 1.2 for the max on that. Okay. Now I'm gonna set my temperature to 85. Put that on auto and put it on heat, and immediately the fuse pops. Got it set to heat. Boom. And it's popping so fast, I'm not even getting increase in the amperage. So it's not like, I mean, it's so fast. Probably should have checked it on inrush, but and I can hear the furnace going. It pops it so fast that I didn't even pick up a reading. The meter didn't even pick up a reading on that. On the I was expecting to see. So it's like a dead short. It's not so much as it's ramping up on current. It's just like it's a dead short, and it's something to do with the furnace. All right. Now, obviously, after that fuse pops, it kills the power that's going to this thermostat. And so that's what we have going on. Track this down. As you can see, blown fuse, which is what I discovered when I got here. Now, when I'm troubleshooting things like this, I typically won't keep using my fuses. I go to using a resettable breaker, which I'll be getting next. All right, performing test again. This time using inrush. Got my resettable breaker in there. I'm not gonna keep using my fuses. And as you can see, it's back on. Let's turn that to heat. See what happens. Got my boom. Heard the click. Okay, it's doing its job. It's resetting each time. Let's go ahead and turn this off. It's visibly messing with the power in here. And my inrush was came up as a negative. It just came back up. So there's two things you got to see. Negative 35 amps. Why is it negative? I think I got dead short somewhere. But 35 amps is way more than that unit should be pulling, which is why every time the furnace goes to come on, it blows the fuse. Now the furnace is like going through its cycle, but as soon as that baby goes to try to light, it's pulling a little over 35 amps. And I had it on the wrong wire earlier, but yeah, I had to use an inrush. Now I'm gonna turn it off of inrush, and I'm gonna go to max, and I'll see if I can duplicate the results. And I'm using this wireless snap-on test light to check my voltage. So my power is back, and the clicks are pretty loud and audible on that resettable breaker right here, which I like. And I can see the lights flickering in here when it happens. And I think I've lost some lights. All right, so set that to 75. And this is just to see if I could pick it up on the min-max. Heat. I'm just gonna let it click one time. And it's ramping up. Furnace hadn't tried to start yet. Boom, it's off. All right. So I'll try to see. Yeah, that has not Now it's doing it even if it's not on the heat. Okay, so as you can see, this the inrush feature is useful because in something that's that quick, the meter's not picking it up, even though I have it set to amps DC and I have it set to max. It's not picking it up, but when I put it on inrush, I could see it. Another reason that is better, that is good to have a very robust meter like this, because if I didn't have the inrush feature, I would have missed that. You see what I mean? I would not have caught that. All right. And that breaker is fast. It's a fast reset. All right, so I want to make sure this is off. That's on auto. That's on low before I put my breaker back in. So I definitely have an issue with furnace. Stick this back in. Put my resettable breaker back in, and we'll start over. So check my power. I got my power, and let's take a look at my line that I'm chasing. Looks like it's red with black trace. That's what I'm going after. Red with black trace. All right, this would be the problem with the water pump. It just runs and runs and runs because it's all cracked up and busted. So to figure that out, I simply turned on the city water to see what would happen, and this is what's happening. I'll be turning that off now. Now, let me take another look, make sure, is that the only place? Yeah, it's just the pump itself. Now, on to our furnaces. This is gonna make it easy to know which furnace is not working, because this one's on, so it's this one. Okay, so that's the one that's not working. That's the one that we're having a short in it somewhere. So I have to figure that out. Okay, so pretty nice design. You can just flip this up. Old Fluke wood. And turns out that the problem with the water is probably going to be affecting our furnace. As you can see from the water just being on for that little bit, there's a pretty bad leak right here. There's also another leak in here, and look where it's leaking at. Directly on top of the furnace, coming all the way through, going to the bottom. So that's definitely going to be a problem. So we're going to have to revisit this. The leak's got to be taken care of, and then the furnace needs to dry out, and then we can diagnose the furnace. Can't even work on the furnace until we get the leaks, because the water, all of that water that's right on the connector and pooling up in the furnace there, it's not supposed to be like that. So that's gonna greatly contribute to our issue. So have to come back, get these leaks sorted out, and then work on the furnace. The other furnace works because it's away from the leak. So didn't expect that one, but that's what we got. And water does conduct electricity pretty well. If you have your, say, like a limit switch or any type of switch that's covered in water, well, that's a dead short, because the water is on the frame and the water is on the electrical connection, giving me my short to ground situation, negative 35 amps on the inrush. All right, I'm gonna close this up and get out of here.